Hey everyone, welcome to problem number 26, remove duplicates from sorted array. Okay, so it's an easy difficulty one. There's a lot going on in here, so we'll go line by line, see what's in it actually, and what do we have to return. Okay, so given an array, integer array nums sorted in non-decreasing order, remove the duplicates in place such that each unique element appear only once. That's what basically removing the duplicates mean. The relative order of the elements should be kept the same. Okay, the return then return the number of unique elements in the nums. Okay, so basically we have to return an integer, that is total number of unique elements in nums array. Okay, but we have to keep them so we have to do this in place. Okay, so these are the two cues from the description. So consider the number of unique elements of the nums to be k. To get accepted, you need to do the following things. Change the array nums such that the first k elements of the nums contain the unique elements in the order they were present in nums initially. So the order is of the importance to us. The remaining elements of nums are not important, as well as the size of the nums. So we don't actually care what the remaining nums would have. All we care about is the size itself. Okay, and then we will return the k. K is the number of unique elements. Okay, as it says. So here, so if the nums is 1 1 2, we have to return 2 because it's 1 and 2 and we don't care what do we have in front. Okay, similarly if we have this nums from then when we have to return 5 with first 5 elements being unique and rest they don't actually care. Okay, so what are the constraints? So nums dot length could go from 1 to 3 raised to 10 raised to 4, so possibility of running into memory is high. um, um, and the each number would actually be from -100 to +100. Okay, and the nums is in sorted non-decreasing order. So what all we can do, well, this is an easy difficulty one, so you can actually use the function sorted. So the order is of importance, but the numbers itself are in the sorted order. So sorting in place is something that we can totally use. So if we do something this, then it basically sorts sorted nums. So basically whatever we have sorted, it just does it in place. This is the Pythonic way of doing it, but now we have to find the unique elements, so we can just wrap it around the sets, and that's pretty much it. And then we will just return alien of nums and it should be just fine. Let's just run this. Okay, see, and submit. Okay, then this is the first approach. If the interviewer doesn't allow this, then we have to go a little longer way. Okay, so let's focus on the first example, right? This one. So what exactly is happening is we don't care what it comes afterwards. All we care about is the unique elements. So a simple for loop could do a trick. So just bear me while I write this code. So let's say we have j equals 0, and for I in range 1 to ln of nums, and so out of this, okay, so j is 0, this is j, and this is I. So if I and j match, we don't care. So what we care about when I, and then we will just increment I. When I and j do not match, that's where what we can do, just replace, we'll just increment j, and we will just mark j to be 1, right? Because anyway we have to do it in place, right? And we don't actually care. So now we can do is increment I and j match, we don't care. We increment I and j match, and now there is again a mismatch. So what we can do is increase j and write 2 here, right? Again, I increment, it matches, I increment, then we increment j, oops, we increment j and mark it 3, and so on and so forth. So this is 4, right, at the time it reaches here, right? So, and what do we have to return? So basically we can just return j plus 1 because till j everything is unique. Yeah. So what we can do here, oops, if nums of j doesn't match nums of I, right? If it matches, we just skip through I, right? So if they don't match, we increment j by 1, nums of j is equal to nums of I. Simple as that. And at the end, we'll just return j plus 1. That's it. Okay, hit the run. Okay, and submit. That's pretty much it. See, the given in place sorted function is much faster as compared to this particular approach. But yeah, as far as the passing all the test cases is concerned, we have cleared in both. So yeah, both of them are fine. Anyway, it's an easy difficulty one, right? Perfect. And thank you so very much for tuning in. For more such videos, stay tuned in. I'll see you guys in the next video. Cheers.